Hello everyone, myself Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss Module 3, Definitions and Terminology. That means in the DC machines, definitions and terminology, we are going to discuss in this video lecture. So here total 15 definitions. First one, where field winding is mounted in the DC machine. So field winding is wound on the field pole core. Here this is the pole core. This is pole core. This is a pole core, and this one is pole shoe. Pole shoe. And if suppose this is the DC machine, this is the pole core, and this one is pole core, and this one is the pole shoe. So here field winding is mounted on the DC machine. So here field winding is mounted on pole core on the stator. This is stator, and armature is wound in the slots. So here armature is wound on the slots on the cylindrical core, and field winding is wound on the rotor. So field winding always mounted on the stator of the pole core. And second question, mention the function of yoke. What do you mean by yoke? Yoke is a protective cover. It acts as a mechanical. See the figure. So this is a yoke. So it acts as a protective cover. So it protects from the dust particles. Now if you see here, it also provides low reluctance path for the magnetic field. Now here it protects the entire machine from the dust and particles, and it provides the mechanical support for the feed. This is the yoke, this one is the yoke, and this is the pole core. So for this pole, it provides the mechanical supports. So this is pole core, pole shoe. Complete this one is the pole shoe, poles. So for this particular poles, this yoke provides mechanical support. So here, and it provides low reluctance path for this magnetic field, and also it provides return paths for the magnetic flux. It acts as a protective cover for the DC machine. Next, third one, mention the part name that is used in the construction of DC machine but not in AC machine. So of course it is a commutator. So commutator means commutator in the DC machine, it will convert from AC to the DC in case of DC generator. So now here the commutator is a mechanical rectification process to convert from AC to output DC, and in the AC machine we do not need rectification process. Directly we will get AC supply. So here in the DC machine, the DC generator, we will get the AC. In the armature, we will get sine wave. So this is AC. So from the AC, commutator will convert from AC to the DC. There is a rectification process is required in case of DC machine. Now, what will happen then if DC motor is connected to AC supply? If this is the DC motor. This is the DC motor if it is connected to the DC. So if you, depending on the supply, motors are classified into the two types, AC motors and DC motor. If you give DC supply to the AC motor, if your DC motor is connected to the AC supply, what will happen? So here current passes through there are brushes and commutator and to the armature winding. This is A and AA, and while passes through the commutator, it is converted into the AC to the DC. So if suppose this is AC, and if it is given to the this DC armature winding through the brushes and commutator, so commutator main function is it will convert from AC to the DC. So that the group of conductors under successive pole carries same current. So this is important. If it is same current means flux per pole remains constant. Here flux per pole remains constant here. Now it does not vary. And now there is a production of heat due to flow of eddy currents in field winding, and motor will be burned. Next, fourth one. Mention the reason for armature of DC motor is laminated. So armature of the DC motor, main purpose of lamination is to reduce the eddy current losses. So first, and there are two types of losses: eddy current losses and hysteresis losses. To reduce the eddy current losses, we will do the laminations for the core, and for the hysteresis losses we will use silicon steel material we will use for the core. Armature is built in the cylindrical or drum shape high grade silicon steel. So this is for to reduce the hysteresis losses. If it is in the form of lamination, that is to reduce the eddy current losses. By using lamination, the circular path of eddy currents is terminated, hence heating and ultimately damage to the armature can be reduced by the lamination. Means to reduce the eddy current losses we will use laminated armature core. Now here, next question, sixth one. So list out the reasons for DC motor preferred for traction purpose. Traction purpose means, see the answer first here. So speed is EB is directly proportional to the Zn 5 by 60, and also next torque is directly proportional to the speed is directly proportional to the torque, and here torque is proportional to the I square. This is the reason. So here we need there is a linear magnetization. So if DC motors used for traction as according to the characteristics of DC motor, so here speed is inversely proportional to the torque. So torques, this is inversely proportional, and this is directly proportional to the square of current. Now here there is a linear magnetization concern, so DC motors are preferably suitable for traction. Next, name the load applications that normally need starting torque more than rated torque. So here, so conveyor, the application is conveyors. So it needs high starting torque. So high starting torque means, so what are the what type of motors having high starting and high starting torque? DC series motors. So DC series motors used as a conveyors. So it provides high starting torque. So at starting torque more than rated torque. So it requires that motor means that is high starting torque means that is DC series motor. Here the DC series motor examples are conveyor belts. Next, mention the name of the motor that can be used to drive the rotary compressor. Now here rotary compressor generally demands it is a constant speed operation. So constant speed operation means so which maintains the constant speed. So synchronous speed, that speed should be always fixed 120 F by P. So that type of motor available here, that is synchronous motor. So rotary compressor generally demands constant speed operation throughout the load. So irrespective of the load, so the speed must be constant. So such type of motors are known as synchronous motors. So DC motors are not able to produce constant speed throughout the process. So DC motors are not examples. Only synchronous machines, synchronous motors, AC motors, not AC motors. In the AC motors again two types: induction motors and synchronous motors. Only synchronous motors maintains the constant speed. So this is the answer, synchronous speed. Now next, mention the motor that is used with flywheel for intermittent light and heavy loads. So here cumulative. So there are in the compound motor there are two types, and cumulative and differential DC motors. Here this type of DC motors is used for freewheel carrying peaks for maximum and for smooth out the load, on the motor as well as to reduce the peaks on the power systems. So without flywheel, the motor construction will be much larger. Next, 10th one. Separately excited DC motors are still used for what purpose? Next, separately excited DC motors are still used in, so here this applications, Ward Leonard speed control method. So in this case, so separate field is required. So separate field, separately field excited here, separate field is excitation here. This one is the load. This one is the supply. So we supply voltage, and this is A and AA, and this is F and FF. So for separately here in this Watt Leonard speed control applications, so there is, it requires separate field and separate supply. So in that case, in that applications we will use separately excited DC motor. So wide output voltage control. So in this wide output voltage control, so that application is well. In the power plants today, AC generators are used due to low cost and less maintenance is required. So because of this reason. Next, lane. Why in the world today 25% of around 25% of motors are manufactured are DC motors. So here the advantages. So the main attraction lies here, flexibility and versatility, okay, and easy of controlling this one. And this explains why in spite of rather heavy initial investment, still it remains its charm in this strong competitive industrial applications. Next, the name motor that can replace DC series motor. So DC series motor closest, so wound rotor induction motor. So we can replace this one. So here motors are classified into two types, DC motors and AC motors. In the again AC motors and induction motor and synchronous motors. In the synchronous motors, induction motors again 3-phase and single phase, and in this wound rotor and squirrel cage. So this this wound rotor can replace the DC series motor. Here in the wound rotor we can control the rotor resistance. We can add the resistance. We can change the rotor resistance value. For rotor resistance control can be possible in the wound rotor. This we can call it as slip ring induction motor. So but ultimately availability and economics of DC power is a deciding factor rather than the motor characteristics. Next, 13th one. Which motor has almost replaced DC shunt motor from its application? DC shunt motor applications means, okay, due to the relative simplicity, so DC series motor characteristics and cheapness and ruggedness and of squirrel cage induction motor. So here DC shunt motor is squirrel cage induction motor. DC series motor is the wound rotor. So here we can replace DC shunt motor as a squirrel cage induction motor because of simplicity, cheapness, means next ruggedness, and this DC motors can be replaced. And the is less preferred constant speed drives DC shunt motors except low speed. At high and medium speed applications, we use induction motors mostly squirrel cage. Next, where DC motor is still used instead of synchronous motor. So at low speed, DC motors are comparable with synchronous motor. If you compare with synchronous motors, so at low speed, so DC shunt motors are comparable. An outstanding feature of DC shunt motor is so wide range of flexible speed control above and below. So here solids where we are using here, so base speed using So above and below base speed using solid state controlled rectifiers. Next, 15th one. Mention the type of motor which is preferred for the lathe machines. Next, here the machines, this type of lathe machines requires uniform torque, which is provided with the squirrel cage induction or DC shunt motors. So hence they are preferred for this lathe machines. DC motors and induction motors of squirrel cage type follow same shunt characteristics. So these are the total 15 definitions in the third module, DC machines. So definitions and terminology. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.